Okay, all right. So this is an API documentation workshop, and I just want to get a better sense of the audience here. If you are currently doing API documentation or you've done API documentation in the past, raise your hand. So about 5. Okay. So I'm assuming that the rest of you are new to API documentation. If you're totally new, raise your hand. All right, now if you're a programmer, like if you're an engineer who maybe you're a former software engineer or you know Java or something, raise your hand. I just want to know. Okay, so wow, wait, what languages? Actually, that's all right. So we have a good number of people who are actually software engineers. Great. That gives me a good sense of things. So if you do have a laptop, great. I do have some activities planned. If you don't, that's fine as well. But this is one of my favorite topics, actually. It's one of the most challenging topics as well, because if you're not a programmer, and I'm not a programmer, there's a lot of difficult things to navigate in this landscape. At the same time, it is by far the most lucrative specialization in tech writing. It's the most challenging, and therefore often the most rewarding. And it's probably the most innovative space. There's lots of cool stuff happening in this space. Things are moving extremely fast. All right, so let me start off with a survey that was done by the Programmable Web. This is a company that basically really just checks out APIs in every respect. They publish a lot about APIs, and they did a survey asking people to rank the most important factors in an API. And what do you see at the top? Complete and accurate documentation rated as the #1 factor in an API. Actually, this is a misnomer. I didn't mean to put API documentation in APIs themselves. So the other things, of course, it's got to work. It's got to have a good community, good service level agreement. But documentation is the most important thing. Isn't that kind of mind-blowing? Like, in this space, this is the thing that people care about the most. And yet, it doesn't often receive a lot of the attention. And when APIs don't receive good documentation attention, you get reactions like this. This is the presentation by John Musser, who's a founder of Programmable Web. He says, the #1 reason that developers hate your API is because your documentation sucks. And then he lists 9 other reasons. But this is the top reason that he leads off with. So navigating the API doc world, in my view, is a little bit like landing on Mars. At least how I think it might be. The terrain is different. The way you breathe is different. In the API doc space, you're interacting with developers, so your audience is different. You're working in different languages, like programming languages. And you just have a lot of different things. A lot of the common tech comm tools don't really work well in the space. If you have reference documentation, you may be using auto-generated methods. So it's like a whole new landscape to navigate. And part of that makes it fun, because it's not the same old thing. But also that makes it kind of difficult, because there's not a tremendous amount of information about API, how to do API documentation. If you want to find a book on it, good luck. There's really not much out there. One reason why API documentation is so hot, and this is an ad that was for a contract API tech writer in Palo Alto. It says, the client wants to find somebody who will emulate Dropbox's developer documentation. And why is it that these companies are searching for API doc writers? Well, it's because the product is the interface when it comes to API documentation. Whereas with traditional software, you have some kind of GUI, and people can use the documentation if they want, but they'll figure it out themselves in the graphical user interface. That's not the case with API docs. The documentation is the product that you're navigating, or at least it's the product interface that you're navigating. So it's got to look good, it's got to be functional, it's got to be clear. Otherwise, it's going to be a bad user experience. You really can't just bypass the documentation in APIs. So, sensing a great dearth of information, when last year I was asked to be a guest editor for STC's intercom issue, and the person asked me to do it on trends, and I thought, wow, you know, I don't want to do another issue on trends. The trend that is the trend is API documentation. So let's focus the whole issue on that. So I helped kind of edit and collect a bunch of different articles, and you can actually download this whole issue for free at that bit.ly link right there. There's a lot of good information, but whoops, I know there's a feedback range in which I'll be sending loud signals. So check that out, and I'll list some other resources, but it's a good way to kind of get your feet wet in API documentation. All right, a little bit about me. I'm not like a veteran API doc writer, just I'll let you know. I've been in this space 2+ years doing API docs, been in the TechCom space a lot longer, but I enjoy it. I'm a humanities background. I majored in English and creative writing, so you know, I love doing code with websites. I used to be a WordPress consultant and built websites and themes and so forth for people, but not like a former engineer or anything. So, and that's significant in this space because a lot of, I'd say at least 1/3 of the people doing API documentation are former engineers. And I have a blog and a podcast at I'dRatherBeWriting.com. I actually have a whole series of podcasts on API documentation. So if you really want to just dive into this, check out this series. I interviewed at least 12 different people in this space, or maybe 10, maybe not 12. Really gathered a great amount of a variety of perspectives with some really top-notch people. So anyway, this is what we're going to do. We have a whole hour and a half, and we'll start out with an overview. We're going to deep dive into REST APIs and then into Javadoc, because they're really different. They're significantly different. But in this overview, you're going to get a taste of everything. If you have questions, feel free to raise your hand. You don't have to wait until the end. I'd be happy to answer whatever, or let me know if I'm doing anything annoying, and I'll try to change it. Okay, any questions before we jump in? All right, let's get into an overview. Here's some basics about APIs. It stands for Application Programming Interface. And basically what it means is that it's like a cog between two systems that helps them interact. You have system A and system B, and the thing that allows them to talk to each other is the API. And there are lots of different kinds of APIs. The REST APIs are probably the most common right now because you can interact over the web. But there are lots of other APIs, and many that I won't even talk about. There are hardware APIs, and there are lots of different types. But it's basically an interface between two systems. There's another term that you may hear called an SDK, which stands for Software Development Kit. And what's the relationship between the two? Well, an SDK provides like tooling for an API. So for example, I used to work at a company called Badgeville. It was a gamification company. And we had a REST API, which was how most people interacted. Gamification is where you add fun game-like elements to some kind of work context. So the user gets points for doing something, you want to give them rewards and little badges and things like that. So people could integrate all of this gamification by making calls to the REST API to get maybe the user's name and points and rewards. But in order to make it easier for people to integrate on their web page, they actually used a JavaScript SDK, which allowed them to use JavaScript in order to make the REST calls and to take the information and process it. So the SDK is just kind of like a tooling companion for an API. There are at least two huge deliverables to be aware of with API documentation. One of them receives the majority of the attention. That's the reference material, but the programmer guides, the user guides, are actually probably more important. But the reference material lists all the classes or all the endpoints, the parameters. It's kind of just a reference of what all the components are. A lot of times the engineers will write that. or they'll put information somewhere that lists the basics. Maybe it's from an engineering spec, but usually, this is written down somewhere. They're not just building things in the dark. It's usually the technical writer's responsibility to make sense of this in real business scenarios. How does somebody use this API to accomplish an actual business goal? So you'll probably work on both, but the emphasis and your responsibility is usually more on the user guide for them. So now I mentioned at least two main types of APIs. The one is called the REST API, which works over the web. But there's a more traditional API, which I'm calling a platform API. And these platform APIs, such as with Java or C++ or .NET, the way you publish documentation, the reference documentation is a little different. You actually write the documentation in the source code of the actual API. You put it in these little doc blocks, as some people call them, asterisks. And then there's usually a parser that will look through all these code files, pull out the information, look for certain tags like param for parameter or throws for like exceptions, and it will format it in something that looks like this. This is Javadoc's Java documentation. This is a standard format. So almost any Java API is going to have documentation that usually looks exactly like this. You can skin it a little bit, but it's not very flexible at all. There's, with C++, a very common document generator, as they're called, is one called Doxygen. It's a little more flexible because you can add additional documents. You can add tutorials and things and set things up, but you're very limited. It's a website in a box that it spits out, and it lists all the classes, and people can navigate that way. So that's platform documentation. And if you want a great example of this, check out this page here. This is Dropbox's developer guides. And if you look through a lot of these different these API references, Ruby, Python, they're all generated with different document generators. Almost every language has its own document generator. So for example, PHP, there's a document generator specifically designed for PHP, and so forth. So that's why a lot of things vary in this landscape, but all of these document generators work pretty much the same way. They have comments in the code, they have special tags that the parsers recognize, and you work within the code in order to generate that reference material. Now, there are certain pros about working in the source material, because it's usually not common to actually be in the code where all the API stuff is happening and have your documentation there. I mean, it's not necessarily a paradigm that's common in tech comm. But there are lots of pros, and this is how developers like to do it. One is that it prevents something called documentation drift. All right, if you have the code separate from the user guides, well, pretty soon developers might be adding new parameters that don't get documented, and they might have new classes that aren't documented, and after a while, the documentation is out of date. But by putting the documentation right in the source code, not only do you allow engineers to more easily update it, but these document generators will actually check to make sure that every parameter and every class or every function is actually in the documentation. They'll produce errors if not. Now, there are some cons with pros and cons with platform APIs. In order for somebody to actually start using a platform API, you have to send them a bunch of code, like a library of these files, and then they'll incorporate it into their project on their local machine. It's faster usually, and it's more secure. But think about the next time you want to have the person update that, right? They've already incorporated it into their project. They've already tested it all, and now you want them to upgrade to the next release. A lot of times they don't want to do it. Additionally, the language coverage. If you write an API in Java, it's great for people who are working in Java, but then you'll have lots of people working in .NET or in C++. So your developers have to create a different API for every single language, which can be a lot more difficult to maintain. So because of this, I think there's been a tremendous rise in REST APIs. REST APIs, this shows the growth of REST APIs. In the last 8 years or so, they have increased dramatically. And the reason, and sometimes people call these web APIs because they really work with the same protocol as the web. With the web, right, you type in an address. Let's say you go to tcworld.com or something, and you get back information. The REST API works in a very similar way. You type in an endpoint, or you pass in an endpoint, and you get back information. So this is a sample with a Flickr endpoint, and by using the word endpoint, I'm really just talking about some kind of online resource that you're accessing through a URL. But endpoint is typically the term used. And then you get back a response. This response happens to be in JSON format with key value pairs. But sometimes the response is in XML. But mostly JSON is the predominant format. Now, in addition to passing certain endpoints, I want to get that water, but if I go over to the speakers, yeah, will you just grab it for me? I think I'm going to get it into a feedback loop there. Thanks. Appreciate it. So in addition to having specific endpoints, there's also parameters that you include in the endpoints. For example, if you want to specify the format, you can do that here. If format equals JSON. Per page, like how many results per page, your API key, and other details. So one of the huge tasks, one of the main tasks in API documentation is to list out all the parameters that each endpoint has. They're very specific categories of things to document with each endpoint. So in this respect, API documentation is highly structured in the sense that you have very specific sections that should be covered for every specific endpoint. One of the frequent ways to test the various endpoints is through something called curl. This is like a way to go to these endpoints using a command line terminal, and you can use different methods. Retrieve basically just pulls the information, but you can also make edits. Let's say you wanted to change somebody's name, or if you wanted to delete some kind of object or do some other actions. So just be aware of the curl. It's commonly used when people are trying to demonstrate like calls and responses. Okay. Any questions about anything so far? Am I going too fast, or is this good? Okay. Okay. So I did a survey on my blog a while back. Actually not very long, a few months ago. Just kind of getting a general lay of the land with API documentation, because I feel like experiences vary dramatically. You may be involved in one IT shop, they do things one way, but how do you know if that's how most other people do it? So I did a survey. What are the types of APIs that most writers document? REST APIs were the #1, followed by Java and C++ and .NET. .NET is going to be all the Microsoft stuff, and then there's some other stragglers. But by and large, REST, Java, C++ are the top of the list. This is helpful if you're trying to figure out what languages to learn, right? REST is not a language, it's just a protocol. But the others are very language specific. It's going to be very difficult to do any of these other documentation types, Java, C++, .NET, without being familiar at some level with the language.
I have a question.
Yes?
Can you tell us in the previous slide, can you tell us where Yang models lie in this landscape?
Where what models lie?
Yang models.
Yang models? YNG? I have never heard of YNG models.
Data models?
Yang data models? Does anybody know or have any answers? Follow up with me afterwards. Sorry, I just really haven't heard of YNG, Yang data models. Could be on there. This was just a brief survey. There were only about 42 people. There could be lots of other industries that maybe work with different data types entirely. And a lot of people I polled on this are from an API documentation group on LinkedIn, which is a great resource. So anyway, sorry. Any other questions? Yeah.
What is the level of proficiency you require, like elementary or for Java and C++?
So what level of proficiency do you need to really document some of these others? That's a great question. It depends how much you want to contribute to the documentation. Let's say that you just want to edit the material, right? You want to make sure that it's clear and that it's styled according to Javadoc style. Well, then you don't have to know that much. But if you want to, let's say you're a power technical writer, maybe the developers don't write anything. Well, then you're going to have to know Java extremely well in order to understand, well, maybe not extremely well. You're going to have to know it a lot more in order to document the different things. So yeah, it depends. You want to contribute. The more you know, the better you can contribute. But you have to at least know all the different parts, like what a constructor is, for example, versus a class versus a method, and the basics, so that you can understand the different parts of where it's going on. It's not the case with REST APIs. REST APIs, they're not going to require you to know a lot of programming at all, really. Even though a lot of people who do document REST APIs often know programming languages and use them with code samples and so forth, the REST language itself is not a programming language. Any other questions? Okay. I wanted to know how many people are automating the REST API docs. You know how the platform docs are they're generated through these document generators where you have these comments in the code. Well, with REST, that's not usually done. Usually REST is done independently. You don't really have all your source API files marked up with documentation in text. And it's the case. There are some methods of doing automated REST API docs, though, and some people are doing it. And I'll talk about those a bit later. So what kind of authoring tools are people using with API documentation? And some of these questions in the survey were kind of poor, and this was probably one of them. But this is mostly related to programming guides. If you're going to create that programming guide, what tools do you use? Well, people use lots of different tools, and there's no common one. Confluence was probably the most common response, but I don't know if that is mostly some kind of internal collaboration tool, or if people are really publishing the API docs with that. There really is no clear tool. Do you test out the API calls yourself? How techie do you have to be, right? You have to get in there and really know how to do it? Well, a little over half actually do. So if you're not testing out the calls, then you're just taking the engineer's word for the fact that it works. All right, that's another survey question. What IDE do you use? So somebody tell me, what does IDE stand for?
Integrated development.
Great, okay. Just kind of checking things now and then. Yeah, so Eclipse is by far the most common, which is great because Eclipse is free and it's really well designed. You can do lots of different languages in it, or at least several. Visual Studio, IntelliJ, Xcode, people use different ones, but by far Eclipse is a common one to know. And this only really relates if you're doing the platform APIs, not necessarily the rest. All right, most common programming languages tech writers know: Java, JavaScript, Python, C++, and C# and PHP. Actually, as a kind of reference check for this response, I was searching for what are the most common programming languages, just across different forums, and they aligned exactly. These are the top 6, maybe not in the exact order, but definitely these are the top 6 languages to know. So if you're going to sit down and learn or stand up and learn a programming language, you're going to invest months of time, right? So you want to make sure you're learning the ones that are going to be the most useful. And a lot of times jobs will say, must know at least one main programming language, such as Java, Python, or C++. So sometimes people just want you to be familiar with how programmers think, with basic programming concepts, like certain logic, the way things are approached. So yeah, other companies really want you to know a specific language, so it just varies. Do developers write the initial API documentation in the source code? About a third say yes, a third say no, a third say sometimes, so could be all over the place. Maybe engineers have some kind of internal wiki where they list everything, or maybe they don't write anything at all. So it's kind of all over the place in terms of what level of involvement do tech writers have in API docs. Some have a lot of involvement, some have very little involvement. Do you write doc by looking in the source code? I actually asked this question because one of the API writers that I know had posted this message on LinkedIn saying that he just finished documenting a Java project entirely from scratch. And I was like, wow, you mean there was absolutely no comment, nothing written at all. You just had the raw source code and you figured out all the parameters of what they mean and all the descriptions of everything. And yeah, apparently he was a former engineer, so I don't know. But how common is that? It's hard to judge. People may peer into the source code because something isn't clear. Maybe it wasn't clear what the data type was for a certain argument. Well, you have to go check the source code. Well, does that mean you're writing the doc by entirely driving it from the source code? I don't know. But you definitely get your hands dirty into the code. How do you access the code? This is a huge question, right? Because developers aren't just going to send you an email with a bunch of code. You have to plug into their workflow, and they've got these workflows driven by revision controls such as Git and Perforce and Mercurial. Some people don't have any access to the code at all, right? And if you don't have access, then probably not editing that code. Maybe in this scenario, people are just creating the programmer guides while the engineers do the reference guides. So there's a lot of variation in how this all works. The most difficult part of API docs, what is it? Understanding the code, getting information from engineers, creating the non-reference documentation, understanding the audience, identifying dependencies between things. This last item maybe requires a little bit of explanation. The API reference is just a feature by feature sort of approach to documentation. It lists the class and so forth, but you don't know maybe what is required to do, what somebody has to do before they can use a certain class. For example, maybe you have to get an ID before you can access the user's points, before you can get what mission they're on or something. So there's a lot of interrelations that aren't usually clarified in reference documentation. Trying to bring those out is difficult. But yeah, understanding the code and getting information from engineers are huge points. People have told me, I've asked engineers before, what's the best way to learn programming? And yeah, I thought they would say, oh, just go learn online. There's lots of resources. Well, sure. That will only take you so far. They say that a lot of the code is very domain specific. So if you're in advertising technology, the way people use Java is going to be very different from the way people use Java in maybe a military organization or something, right? So different domains have different uses, and especially with some of these robust languages, there are lots of different packages and different plugins and things like that people are using. Finally, I think this is my last question in the survey. How did you learn what you needed to know? A lot of people interacted with developers. So this is a space where you've got to be brave enough to go over to a developer's cube and say, how does this work? And of course, most developers I've worked with, well, sometimes, I guess I shouldn't say most because it varies. Some people are more than happy to explain something in great depth, and sometimes I feel like developers like to show how much they know and how little you know, and so there's that sense. But other times, people they're just friendly and they're passionate, and when somebody shows an interest in this code that nobody else really ever takes an interest in, they're excited about it. So you have to interact with them. Other people are self-taught, and So you're never gonna get a job where people say, okay, we're gonna now train you on this programming language. You're gonna have to figure out a lot of it on your own. Interacting with developers, learning it on your own, and whatever other courses you can take. But most companies won't really train you on this. A lot of people are actually former engineers, and some people took classes in college, apparently. My favorite online resource is Safari Books Online. It's kind of expensive though. It's like 25 bucks a month. Lynda.com is about the same, and it's a great resource as well. But there are other resources such as Udemy, UDEMY, and lots of others that you'll find online in order to learn a lot of these things. But you'll only really learn the basics. Like you can only get so far trying to learn something online before you have to actually be involved in a project for an extensive amount of time before you can really move up to another level. Okay, so some takeaways from this survey. Java, Eclipse, Git are popular. Become familiar with getting information from source code and developers. Become a self-learner. REST APIs are common, and automating REST API docs is not that common. All right, now we're going to deep dive into REST APIs. So that was just kind of an overview of API documentation. Any questions, comments? How many of you have laptops? Raise your hand. Oh, wow. Okay, so at least 2/3. Great. So now in this section of the workshop, and let me check our time. 2:30. What do we go to? 3:30 or 3:45? 3:30. So we have another hour. Great. Great. So I've got 3 sections, and maybe they'll each take 30 minutes. So we're going to deep dive into REST APIs. I should go to this slide first. All right. So I actually had this slide in my presentation the other day. Basically, a REST API works like this. You have an endpoint request that goes out to some server where your API is, and the server throws a response back. And usually that response is in JSON, and a developer takes it and processes it in some way. Maybe they use JavaScript to display it on a web page. But that's pretty much how it works. It works almost identical or identically to the way the web works. Every time you're typing something into your browser about where you're going to go, Google, Yahoo, New York Times, whatever, sorry, you're making a request to a server and you're getting information back. So it's the exact same model. Here's some more specific stuff. So REST actually stands for Representational State Transfer. Doesn't mean a whole lot. Basically, one aspect is that the state is not remembered. You go to an endpoint and it always returns the same information. It doesn't remember like your previous one and add on to that or anything. You can see the response in the browser, and it's modeled after the web. Okay, so here's some sample endpoints. Now this is out of a mock API. It's kind of like the gamification API that I was describing. But here's some samples. Let's say you have a basic path, whatever your API is, and then you add your API key, right? Because you don't want anybody to just hit that endpoint. You have to authorize the user. And then you add a path, let's say the users. Now this maybe returns all the users' names. And like I said, this is just a sample, generic way that an API might work. This isn't like how all of APIs work or anything. If you go to users/user ID, maybe you get a specific user rather than a list of users. If you go to /rewards, maybe you get a list of rewards. But if you go to rewards/ a specific reward ID, maybe you get a very specific reward back. If you go to users, user ID /rewards, you get all the rewards for a specific user. And if you go to users/user ID rewards/rewards ID, you get a specific reward for a specific user. That's how the API worked at Badgeville. And so it was very predictable. People who are working with it can kind of get the logic of it and say, let's say there was a mission, right, which is just a collection of different rewards in Badgeville's gamification world. Well, you could probably figure out and make a guess that you'd probably go to missions to get all missions. And if you put users after it, you get the missions for a specific user and so forth. So the logic of the REST APIs follows a predictable pattern. You have different endpoints and different parameters that you pass. Okay, the responses are usually in JSON. JSON is just key value pairs. So user and then the value. User is the key, and value here is 1, 2, 3, 4. And user name and so forth. This is a screenshot. Now the JSON responses can often contain lists of items. And when you have a list of items, in this case photo, it has a photo here and then another photo here and so forth. When you have these lists, they're called arrays. So you can iterate through all this responses, pull out information, and display them. One tool that you will definitely want to get familiar with when you're working with REST APIs is the developer console. So you go to View, Developer, JavaScript console in Chrome, and you get a little sub-pane that pops out, and you can see a lot of cool information. It's very common to log things to the console, and when you do log things to the console, they appear at the bottom. This is a sample console log, and you can log the whole response from JSON into the console and see what comes back. It's very, very useful. And we're going to do an exercise here in a minute, just giving you an overview. Now, there are different methods, right? If you're just passing things over, if you're just using a straight request, you're usually using a get method. You're just getting information. Because if you're going to allow people to delete things or edit things, you have to enforce more security, right? So there's a lot of times an authorization component that makes it more complex. But just keep in mind that there are different methods that each endpoint can use. Some endpoints may not have delete. Maybe it's a get-only method. A get method is just going to retrieve a resource, right? So again, you can use the developer console to see what method is being used for each of the resources. So when you go to my website, for example, you're going to get back a ton of different items. Each separate object on the page is retrieved independently with a specific method. You get a style sheet, you get images, you get text, and they're all using these methods. All right, so if you do have a computer, here's a time where you can do something with it. I have workshop files. If you go to GitHub, you can get them. So if you go to github.com/TomJohnson1492/API workshop, you'll see, I don't think I actually have a screenshot of this. Maybe I will go to it here. You probably have seen this quite commonly on the web, these GitHub repositories. And it's worth noting just how you get the information. There are two ways. There's a download zip button here, which you can use if you just want to grab all the files. So if you click this, you're going to be prompted with a zip file containing all the stuff. So you can just save it. The other option is if, let's say you wanted to basically subscribe to the repository and keep a local copy on your machine, you could do it like this as well. So let's say you want to clone in your desktop. Well, you copy the clone URL. You would open up your iTerminal. Let me clear whatever's there. Navigate to where you want to go. For example, here I'm in my projects directory. Yeah.
Just give them the Wi-Fi password.
Oh yeah, the Wi-Fi password might be helpful.
Folks, the Wi-Fi username is across, ACROSS, and password is tcworld, one word.
Sure. Okay, so let's say you decide you want to get the files in a more technical way, right? Just kind of as a preview. If you have Git installed in your computer, you open up a command line terminal, and basically you would type git clone and then the URL, and it's going to download all those files right into whatever folder you're at. So at any rate, the files contain various exercises, and we're going to go through some of those exercises in a minute. But I just wanted to make sure. Now, if you don't have a computer, don't worry about it. You're not gonna miss out. I'll show you everything. this first example, let's say, now Eventbrite is an event management software. If you're ever holding an event, by the way, Eventbrite is by far the best way to do it. So you can manage registrations essentially. But let's say you wanted to get some event details about your event and you want to use their API. So this is the event details API, and you can create an event, you can retrieve event details and so forth. Let's just get event details. Well, the endpoint is eventbrite.api.com/v3/events and then your event ID. Once you populate it with values, it's going to look like that second section, and there is your response. So you can populate it onto a page by using some JSON code. Because I just wanted to show like how to put this stuff on the page. I wasn't trying to like show code in order to confuse anybody, but you can use jQuery to grab the information from the URL and basically append it somewhere on your page. So here's an example. We had an API workshop with Cermatics, and so let's say you wanted to get the event name and a description and put it on the page. Well, that's what you're going to do here. In this, I think it's, yeah, there we go. We're coming to the activity. But one more thing before we get to the activity. Once you do grab the information, I've logged the endpoint payload to the console, so if you have it open, you will see all this stuff come in, and you can see all the different values and information that is retrieved. Okay, so if you have a computer, you can either go directly to this URL, or you can open the eventbrite.html file in one of the workshop files you downloaded. Either way. So I'll just go to this site here. Oh, I pushed it over there. Okay. And open up my browser there.
Firefox will work?
Huh. Yeah, Firefox will work too. You open up the console a little bit differently. Sorry. Not really sure why my display is not mirrored. Give me a second here. I want to fix something because I can't see on my computer. Okay, there we go. Let me just do that. Because otherwise I have to try to navigate the mouse and I can't see what I'm doing. Okay, so this page doesn't have any of the code that or it doesn't have any of the text that you see there, right? If you're just looking at the text of the page, it's making a call to get this information through the Eventbrite API, and it's putting it on this page. And if I logged the payload to the console, so let me refresh the page, and you can see here that you've got this object that is being retrieved, and it's got a bunch of different information in it. So where is the name and the description? That is the task in this activity. So if you expand this little section here, you can see the name. I guess there's an HTML version and a text version that you can choose. And the description is in here as well somewhere. Description is there. So basically I've made a call to the endpoint. It's retrieved this object, and I've used some basic JavaScript to append these two elements of the response onto the web page so you could see it. So that's essentially how REST APIs work. And we'll do a couple more examples. By the way, even though I've kind of put a code sample in here, code samples should always be really simple. Like, you notice there was no styling in that. It was just plain text, because I'm just trying to show what gets returned in the response. If you were an actual web developer, you would probably do a lot of style. You would add a lot of things to that sort of a call, right? You would make it look pretty. But you just want to use minimal code. You want to be as simple as possible to peel away any sort of distraction that is going to come about. I mentioned that there are specific sections that you want to document in REST APIs. So here are at least 8 sections that should, or 7 sections that should always be covered. What is the endpoint? You know, in this case, it was that Eventbrite/event. What does the endpoint retrieve? You know, describe what it does or what it includes. Whatever parameters you can add to the endpoint, what methods you can use. Can you just get stuff? Can you delete things? What's a success response? What's an error response? And then a sample call. So you usually have a list of different endpoints. You may have 3, you may have 30, whatever. But each endpoint should at least cover these sections. So here, let's do another example. This is Clout. Clout is a service that used to be a lot kind of more popular, but has since sort of died away. At any rate, they have a cool API. And let's say that you wanted to retrieve your Clout score. So your Clout is your online influence. And they measure your influence across a variety of social networks and platforms. And they give you a quantitative score so you know just how influential you are or are not, right? All right, so now they have actually an interactive console where you have to log into this. And when you log in, you see your API key is automatically populated in things. But in this sample scenario, we want to get our score. And you'll see that if you look through the API, you have to pass in your Clout ID first, followed by the score as your end path. Well, how do you get your Clout ID? That's a different endpoint, right? So you have to you can get it through Twitter or something. I think there are 3 different methods you can use, but you will use this other endpoint to get your ID. Your response comes back. And then you can pass it into this other endpoint in order to get your score. So I bring this up just to illustrate that there's usually dependencies between endpoints. Some endpoints are precursors to using other endpoints, and this is one example. And this is another activity file we can do. Well, basically, let me jump ahead here. Here's some sample code. Now, let me just make mention here. This getJSON is a jQuery function that will you put in the URL, in this case the endpoint here, and then you can do something with the data. All we're doing here is basically getting the score from the object returned and appending it onto this ID on the page. And this is what it looks like, right? So not that exciting. My Clout score is really boring, but you can see it. Now, you don't have to use JavaScript to do the code. You could do it in PHP. You could do it in Python. This is part of the beauty of REST APIs. Is you're not limited to one language. People can use whatever language they want as long as they can go to a URL and get a response. So that's why REST APIs are popular. They're not totally dependent on one single language. Another example, one other endpoint in Clout, you can get your influencees. But you'll notice that there's not much information that is provided in reference documentation. They don't tell you what an influencee is, how influence is calculated, or much detail at all. In fact, there's maybe 8, 9 words in that whole description. And I wanted to highlight this because reference docs, they don't usually include a lot of detail. That detail is going to be included more in the programmer guides, in the conceptual introductions. Why would I even want to know my influencees? Those kind of questions, they're not covered here. But you do the same thing. You have an endpoint. You pass in various, well, this is the whole endpoint, the Cloud ID and influence. No parameters here, but you're going to get a response. And here's a sample way to get your response. Now here, this is actually a jQuery method called each. And you know how I showed earlier, you sometimes get a list of things. Well, each is a method that will look through each item in a list and do something with each of those items. So in this case, we're looking through each of the returned items that are influencers and appending them to a specific part of the page. And so this is basically what it looks like. It's just a list. All right, so here's an activity. Go ahead and open up the clout_influence HTML file, or you can just grab it from this online source. And you're going to change the ID to something else. and see the response. All right, so go ahead and do that, and I'll do this here for people who don't have a computer. Let me just grab API Workshop, and this is the Cloud Influence. Okay, so
Could you show the URL again?
yeah, sorry. So if you want to just grab the source code, you could go to tomjohnson1492.github.io/API Workshop /cloud_influence. Okay, so this sample has my Twitter ID, right? But let's pass in a different cloud ID. Sorry, not Twitter ID. I've got one actually in the sample code here, just to save time. This is White House government, right? So you want to see who the government is influencing in the United States, you can pass it in here. Save this, and let me here we go. So you can see how changing the parameters, now you can't see that at all, can you? Changing the parameters changes the response. So Sabari, word of peas, I have no idea. This is probably why the Cloud API kind of died. I'm not really sure what you do with this information. At any rate, that gives you kind of a taste of how REST APIs work. I have one more example. And let me come back here. Any questions or so far from any of the activities? Okay, I have one more example. Flickr. Flickr has a great API. And let's say that you wanted to get a list of gallery photos. A gallery in Flickr is basically a selection of photos that people have chosen as being a part of a specific theme. Well, they have a specific endpoint called flickr.galleries.getPhotos. And you can add different values or different, with the endpoint you have to add different values. So you've got your API key, your gallery ID, and so forth. And then you get a response. But now this time I want you to actually try to look at the response and figure out what the image source URLs are. So you're going to open up your console, refresh your page once you go to this page, and try to find out where the image source URL is. Because let's say you want to create a page that has all of these photos from this gallery. How do you do this? So if you don't have a computer, you can follow along here. So I'm just going to go here, let me open up my JavaScript console, come to this page. Now I've got the payload logged here. Okay, so you can see that I've got a bunch of, this is a gallery from some Flickr photo thing. But if you look in the console, you don't actually see any of the image source URLs if you expand through this and see what's returned. Each of these photo objects doesn't list the URL at all. So how do you take the response and actually construct an image source URL on your page so that you can get images, photos? Well, this is where the reference docs kind of fail you. The answer is not apparent. If you just look through the documentation, you won't find it in the API reference. It turns out that you have to construct it from 4 different responses in the fields, and you get this from one of the tutorials. You have to add the farm ID, server ID, ID, and secret, and all those in combination then form the actual source image URL for each image. So I wanted to highlight this because the reference docs, they don't really describe how to do an actual real case scenario. You have to, you need some kind of tutorial that explains to people how you use the API in a real scenario. Okay. If you want more that's all we're going to go into with REST APIs. If you want more detail, go to this site on my blog. bit.ly/REST API examples, and I walk through this in great detail. So you can get all the information. I've got these 4 case scenarios. You can explore the source files more. Really, there's not a tremendous amount there. Basically, you have an endpoint and it's returning data. And I just wanted to kind of visualize the data in a really simple way on the web page. Okay, so before we jump into a little more about like how people publish REST API information, any questions or comments? I saw a few people leaving, which makes me think maybe they either have another session or maybe they're like, this is too techy, or this is not for me, or what. Maybe I'm just really boring, but anyway, if you're, I wanted to show some code just because this is part of the whole API doc space. I mean, it's you're working in technical things. You're going to get code samples. And the code samples that I've been showing are like preschool code samples compared to production application code, right? If you get something from an actual developer, it's going to be a lot more complicated. All right, well, one of the challenges you have with REST APIs is how to publish the information. And the programmableweb.com has a directory of like 12,000 APIs. So you can browse how different companies are publishing their API documentation. And unsurprisingly, there's a lot of variety in how people do it. What trends or patterns do you see emerging in all of this API doc publishing? Well, I went through and just tried to kind of identify some things that are recurring themes. One is a seamless website that matches their product branding. For example, if you go to Yelp's API, it fits right in with their color scheme, their website, their font, and everything. This kind of ties in a little bit with my talk yesterday about static site generators. They're really popular in the API documentation space because people need to do more with their API docs. They have more, they want to brand them because they are the interface. They want to make the docs look representative of their company and their brand and their style. So it's part of the reason people use them. You'll often see navigation tabs. This is an example from Twilio. They have one output, right? But you have lots of different languages. So how do you represent 8 different ways, 8 different code samples? Are you going to just list them one after the other? Are you going to have a different output for every different code sample? Not usually. Usually people have navigation tabs and people jump from tab to tab. Another common example is to allow people to have real-time requests based on their own data. So for example, with Twitter's API, you sign in, I'm signed in here, and it knows my API key. So now whenever I want to perform one of these calls, it's going to automatically make it so that it's using my own credentials. So you have these interactive real-time API Explorer type of scenarios. That's really common. Another common example, this is from Stripe's API, Stripe API. Of all the APIs that people talk about, this is the one that is usually held up as the greatest one. And it's probably overhyped, but basically they kind of have this side column where they often show code, and then in the left column they have like more narration. So they have this side-by-side code on the right in black, and narration and other details in the middle. So a getting started section is often very common. You want to help people become successful. So you have what's called a Hello World tutorial, and there's even an acronym people use. Time to Hello World means how long did it take me to produce a very basic result with this API. Time TTHW or something. Finally, there are lots of code samples, and the code samples aren't just black text. They're highlighted syntactically. So green, blue, red. It depends on what it's trying to highlight. Different. The code syntax highlighting is actually pretty complicated because you have to make sure you've got the right parser integrated for the right language, because elements in Java or JavaScript are going to differ from HTML or from something else, right? So you have to have a good syntax highlighter in your website in order to have readable code samples. And you find that in many of them. Finally, there's this phenomenon of the single page scroll. And to get the real effect, actually do have a video with this one. So this is the infinite scroll effect. If you look on the left, you'll notice that this keeps changing the highlight, right? And this page is just infinite. It will go all the way down. And this is really common in API doc publishing sites. You just have a very long page. And it's interesting because so many traditional tech comm principles tell us to chunk our information into short bits. And yet developers seem to not want to have to jump from page to page. So maybe you've chunked the information, but here you're gluing it together into one long experience. Not all doc sites do it like this, but there are a significant number. This is actually a feature called Scroll Spy with Bootstrap. So if you want to integrate it, it's not really hard. You just put in the right Bootstrap code. Okay. So now I mentioned that there are some, oh, by the way, any questions about, yes, in the back.
Yeah, so Tom, my name is Amit, and I have one question. Like when we design the API documents, especially for manifest files, how should we actually plan for that?
How should you plan the API documentation for manifest files? So the manifest file is telling you all the different classes within some library? Is that what? Okay. So with platform-specific documentation, you're probably going to be using a document generator, right? That's going to automatically, or no? You can extract out all that information, or you have open options. If you're going to be creating like custom outputs from platform API docs, like let's say you have a bunch of Java files and you want to pull out all that information into a cool looking website rather than Javadoc, you'll probably have to involve a developer to help with custom tooling. That's all I can really comment on. It's a lot harder to get information out of the source code and parse it. But a lot of front-end people have those skills and can do it. I think I'll come back to that a little bit later. But yeah, does anybody have any more thoughts on that? Anybody want to add more of a response? So, other questions, thoughts? The API publishing API docs, I think, is also one area where I think that technical writers could play a significant role. Developers, they're working on code, right? They're not necessarily concerned with publishing. So if you can define a good publishing method, and maybe you work with a UX designer to do it, it can be really instrumental in helping take the code that developers are writing and presenting it in a good professional way. Okay, so I mentioned with REST API docs, for the most part, they're not the documentation is not generated from the source. For the most part, people usually have separate files for their REST API code and their documentation. But there are some auto-generated reference doc solutions. Here are 6, 7 possibilities. One is called Swagger. Raise your hand if you've heard of Swagger. Like 2 people, okay. Raml is another. Enunciate, API Blueprint, Mashery, so forth. So I'm just going to jump into Swagger because it's the most popular. Somebody did a poll. They looked at lots of GitHub repos and found that Swagger was in most of the repositories, which suggests that it's the most popular. And here's an example. This is the Swagger editor. It requires you to put your information in a certain syntax. You actually have a YAML syntax. YAML stands for it ain't markup language or something. Anyway, it's supposed to be human readable. You get an example here about how to structure things, and then the output looks something like this. basically allows you to expand different sections, plug in your own values, and run the API right within the experience. So I have, so I once gave a presentation and people really grilled me on Swagger. So I kind of like had to dive into it. And so I have a lot more text on this slide than I'm usually used to putting on. But basically, Swagger it's a spec, and there are lots of different tools that can process that Swagger spec. It's kind of like Ditto, right? You write in a certain format, and different tools can process that format. And there's one tool called Swagger UI that is pretty common. So as an activity, I want you to check out a sample Swagger project. This is not a real API. This is petstore.swagger.wordnik. But go ahead and go to this section, or go to this site. And for those who don't have a computer, I'll go to it here. And just get a feel for how this sort of thing looks and works. I mentioned that there are lots of different expandable sections. So here I can expand all the stuff about pets, I guess here. And looks like there are about 8 or 9 endpoints. So you can expand your endpoint there or this other one and so forth. So it compresses a lot of information kind of in the single page display experience, right? Where you've got all the information here. And the cool thing about this Swagger is that you can actually get values back from the API directly in here. So there's not a lot of information about what you're supposed to put in here, but basically a pet object, right, that needs to be added to the pet store. So let's say I have a giraffe, right? You can hit this try it out button, and it actually will try to run this. It will take whatever value I added and pass it into some endpoint and try to give me a response. Because this is just a pseudo API, it's not like a real response, but people who use Swagger actually integrate it with their API so that you can run and try out calls right in the interface. And I asked somebody who's done a lot with APIs, Peter Gruenbaum in Seattle, I said, what do you think of these auto generators? Are these useful? Are they cool? Or are they just kind of novel? And he said that they work really well for simple APIs. So for example, here, a lot of these calls, they look somewhat independent. You don't have to do one endpoint in order to get another, or some kind of more sophisticated workflow. And so these sort of try it out experiences within the interface work well. But if you don't really know what values to add, or if you don't have much data in your API to begin with, they're not going to be that instructive. So he mentioned that they may not really help somebody learn how to use the API. So they may be more of a bell and a whistle. But they're kind of cool. Now there's another one called Ramble and so forth, and I won't dive into them, but there are different ways of automating this, and you can actually have your developers put these Swagger libraries inside the code and then generate this output from the code directly. You also have the option of having this external file that's not directly in the code. So you have some different options.
What's the URL again? Petstore?
Yeah, petstore.swagger. Just do Swagger demo. You'll find it. Okay. As one final tip about REST APIs, there's a presentation that is really good. Somebody created with a Write the Docs meetup called Documenting REST APIs, and you can go to it at this URL. It's one of the better presentations I've seen, actually, and there's not too much about documenting REST APIs. I mean, you won't find a lot of information, and this is a good one. But you'll notice this organization, Write the Docs. This is a group. If you have, okay, you're not going to find a Write the Docs meetup in India, but you could form one. It's more of like a group of people who are focused on developer documentation. In contrast to the STC or other kind of TechCom circles where you get more traditional docs, the Write the Docs people are really focusing on more of the developer API type space. Okay, any questions, thoughts? What time is it? Let me see how we're doing. We have 20 minutes. Okay. So usually I've given this API workshop several times, and we never get to the Javadoc part. We always end up, it always ends in the REST APIs. And I put that up front because they're more common, they're more popular, they're more accessible, right? You don't necessarily have to be a programmer to do REST API documentation. You just know the endpoints and the parameters and responses, and you can do it. But this other territory of Javadoc really is going to expose you to what you need to know to do the platform-specific API documentation. And I chose Javadoc because it seems to be one of the more popular ones, but many of the trends could be said about the C++ or Python or other languages. But have never given this part of the presentation before. So a sample Javadoc comment looks, oh wow, that's going to be way too small for people to read. So you have different aspects of the code, and your document generator is going to parse, it's going to look through the tags, and it's going to parse it, and it's going to give you something like this. I mentioned that before. And now actually I have a workshop sample that tries to give a simplified Javadoc, and we'll get into that in a second. But let me just give you a little bit of overview information. Java developers use Javadoc. It's supported by Oracle. A lot of times when people use the Javadoc, they're not accessing it online. They open up the Java library within their IDE, Eclipse or something, and the Javadoc is part of that package. So they access all the Javadoc directly within their interface. So it's right there. And a lot of times different classes are linked so that you can click something and go right to the documentation for it. So in your workshop files, you have I tried to write a small little piece of Java code that would demonstrate different tags and so forth, be something more accessible. And if you go to sample_Java project, you can get to it. And this is what the default little output looks like. And I think I have there we go. Let's jump into one of these, just so we can get a sense of it. Now I also put this online, so if you don't have the workshop files, you can just go directly to this URL, because remember, they're all in the GitHub repository. By the way, yeah, I won't get into that. All right, so here's the sample Javadoc file. Now this one just has a couple of classes, the Acme smartphone class and the Dynamite class. And you can see on the left, you see basically a list of all the classes. You can also browse by package, right? So a package is basically a group of classes. People want to group them to have some sense of order. Imagine if I had 100 classes, right? It would be a really long list. You can also browse by package. And when you go into one of the classes, you see a full description and so forth. But if you are just browsing by package, you see a short description. So all of this stuff is parsed through the Javadoc document generator, and you have to know exactly what it's looking for and style things exactly so that it comes out as you would expect. All right, so let me jump into this. Who writes Javadoc? Well, usually engineers do it poorly, and then tech writers maybe come in and fill in gaps, clarify things. But the general workflow that people follow is people have different branches in these code repositories, and software developers will often work in the main branch, but then it's because they don't want to have you working in the main branch, maybe they don't trust what commits you're going to make or whatever. They'll create a separate documentation branch for the technical writer. And there you make your edits and commit to this branch, and when you're done, then they may review all of your edits and decide to merge this doc branch in with the main branch. So that way you can kind of participate in the same workflow without worrying that you're going to screw up some main code and cause all kinds of frustration. So this comes back to a question somebody asked earlier, how much do you have to know to contribute to Javadoc? Java libraries are highly technical, but one of the things that tech writers can contribute is style, according to a seasoned veteran. And you'll understand what I mean by that in a little bit more as I explain some of the Javadoc style, because it's highly structured. It's not just grammar, it's everything from the whole sentence voice and flow to different parts of the content. Okay, so in order to work with Java, you're going to have to install an IDE, and Eclipse is probably the most common. And if you have Eclipse, you can totally launch it for an upcoming activity. If you don't, that's fine as well. But you'll also need the Java Development Kit installed. This is in order to process the Java. If you want to get the source files, you'll need to install some kind of revision control like Git or Perforce or something else. So there's a lot more setup in order to get it at platform APIs, right? You've got to have an IDE, and you've got to plug into the source control, and you've got to know a programming language. So it's more involved. Let's open up one of these projects. I think I have Eclipse right here. And you can actually import this project. If you downloaded the workshop files, you can import it into Eclipse and kind of play around with it. So I'll leave these instructions here, but I'll also go through them. Basically, you can import them from file, import, and so forth. I've already got this in my project. Wow, this looks tiny. Okay. And we are looking for sample Java project. Okay. So if you expand these guys and you double click one of the Java files, you will see really tiny text. Let me see if I can, it's going to be way too small. Got any ideas how I can magnify that? No. Okay, well, that's why I have screenshots. There's a preview pane at the bottom of most Javadoc files that lets you kind of easily preview how the Javadoc tags and so forth will get rendered into the output. So there are a couple of main concepts just to understand working with Javadoc. One is the most fundamental is a class. What is a class? As an analogy, think of a resume template. You're trying to build a resume, so you download some Word resume template, and you open it up, and then you create your own resume from it. But the template itself still exists, and you can create lots of different resumes from it. So classes are like that in Java. They're kind of like blueprints or templates from which lots of different objects get created. Another example, let's say you have a general bicycle class that's used to create lots of different bicycle types. And in your general class, let's say you have a size field and maybe a role method. Each of those fields and methods in the class get carried down into each of the objects, right? And you'll see this term a lot. Developers use the term instantiate when they're talking about creating an object from a class. So the Javadoc usually consists of lots of different classes, and when people actually use it, they'll make objects from those classes, and they'll use the different methods and so forth. So in the code, what you'll see, this is an example of a class. It's going to actually say the word class. Before it, there's going to be an access modifier that determines who can access it. If it's public, it means anybody can access it. But if it's private, that means it's more of an internal utility class that's not going to be included in the output. So you don't even document it usually. Or if you do, it's not going to be seen by people. In the Javadoc, there are two kinds of tags. If you have 2 asterisks, this is an official Javadoc tag. If you just have one, this is a comment. Or if you just have a double slash, it's a comment as well. So when the Javadoc document generator goes through and looks for tags, it finds a tag with a slash followed by 2 asterisks and uses that in order to pull out the description and look for other relevant material. Okay, we're kind of running out of time, so I'm going to skip this activity. But basically, what's really cool about the IDE here in Eclipse is if you just start typing some things, for example, slash 2 asterisks and hit return, it automatically adds all this other formatting. You probably can't see that, but it adds all this other formatting and just lets you really type and just adds the right asterisk and so forth right directly for you. There's a ton of stuff that's automated in Eclipse, so definitely get familiar with that. So class descriptions have a high structure about them as well. There's usually a short description, which is a sentence long, and after the first period, then begins the long description. So you want to make sure that you've got a substantial first sentence, because that's going to appear as the summary in your package descriptions that give an overview of each of the classes. And you can use HTML tags, but you only use the opening P. It's going to automatically give you a closing tag and other formatting. Now there are certain tags that are allowed in the class description, such as @author, @version, and so forth. These little @tags are going to be rendered into the output and tell you the author and the version and other things. So different elements can have different tags. Here's an example where you see the short description right here, and this is where the first period ends, and then the long description is going to be in the full class page. So I'm just kind of showing you this to show and explain that Javadoc has a very specific syntax that you have to follow in order to get the result that people expect. So in the class description, I mentioned you can have these different tags. But in other elements, such as methods, you're going to have other tags. So a method is like a little subprogram. It's what a class can do. For example, let's say you have a calculator class. Maybe it has the methods add, subtract, divide, and multiply. Right? So a method is just what a class does. And methods, unlike classes, actually take arguments. So here I've got 2 arguments for this class, a city and a state. And before each of the arguments, it has the data type. So this requires a string, right, as opposed to a number or an integer. So documenting exactly what the arguments are for each method and the data type is an important part of Java documentation. Now the tags that you can use in a method are different. I mentioned this. @param lists the parameter. So you basically put a space after @param, name the parameter, but not the data type, city, and then space, and then a description of that parameter. And you do that for each of the parameters in the order that the parameters or the arguments appear for the method. You can also list what the method returns. So some methods actually arrive at some kind of value that they send back to whatever called the method. And you list that here using the @return. If the method throws a specific kind of error, then you list it here. So like I said, the Javadoc is another level of technical detail. You have to know what a parameter is, what a return value does, what kinds of exceptions get thrown. And if you know all these terms and the lingo and how it fits together, then you can contribute to the Javadoc documentation. Now, there's lots of guidelines. I'm not going to get into this, but if you look at like Javadoc style, they'll give you all kinds of detail. For example, you write each parameter as lowercase. You don't put a period at the end. You have to include the parameter regardless, otherwise the Javadoc will throw an error. So there's lots of different things. Now, as a final note here, in order to generate the Javadoc, it's actually quite easy. From Eclipse, you export it directly from Eclipse. So once you have all this stuff, if you just go to File, Export, you'll have an option here. Where was I? Okay. Oh, Javadoc, duh. All right, you choose Javadoc. You choose the methods that you want included from here and so forth. Say you wanted these methods included. You would usually include probably them all. And you hit Finish. I guess, I typed some gibberish there. And it's going to just render it and produce it right there. So you can experiment. You can see, well, what happens when I add this tag? Where does it appear? And you can expand this and see that your tags ended up here and so forth. You can put links and other details. So I hope that gives you somewhat of a taste of Javadoc. Different generators are going to have different tags, different styles, different ways of doing things. But that's the difference. So REST API documentation, a lot more accessible, very web-based. Platform APIs, very programmer-based, more language-specific. They involve document generators. Both of them are challenging and require different levels of expertise. But if you do have a interest in code, this is a huge area to exploit in your career. There's lots of job opportunities, and people are looking for tech writers with this talent. Questions, comments, anything? Any feedback? Yes?
Is there something similar for Python?
Yeah. PyDoc is what is the generator for Python. Python is supposed to be one of the more easier languages to learn. So if you want to start with one, try it with Python. And Python is really useful in a lot of documentation scenarios. This is my contact information. I'd rather be writing.com. There's a great API course. I haven't actually taken it, so maybe I shouldn't say great. But there's an API course on Udemy by Peter Gruenbaum that you should check out. He just pushed it up, published it there. Excuse me. But he's a great resource, and it's one of the first API courses that are available on there.
What's the name of the person?
What? Peter Gruenbaum. I need to go through the course myself just to check it out. But he's a really sharp guy. But look for API. Search for Peter Gruenbaum's name, API docs, and Udemy. I'm sure you'll find it. So, thanks again. You've lasted through the hour and a half of this highly technical subject, and